Mm, Hey, hey there. Today, let us. Hello everyone. Today we are going to learn about CUDA program that actually tells about the matrix addition, where two matrices are actually added together. We'll be using GPU parallelism for that. So, let's break down into parts and understand how actually the code works. The C++ one. So first we have three CUDA kernel functions. So these actually run the GPU, but to do the matrix addition in parallel. So let me show you that. So one is matrix add C, matrix add B is the second one, matrix add D is the third one. So coming to matrix add C, this kernel uses 1D grid of threads. So each thread picks up a row index of I and then loop through all columns J. So corresponding each elements from matrix A and B. So this will be storing in C element. Okay. Then coming to matrix add B. So this kernel actually uses 2D grid. So 2D blocks of the threads. So each thread calculates both i's row and j column. So every thread handles single element of matrix that will be directly handling. So there's no issue. So it indices actually, that performs the addition here. So coming to matrix add D. So here similar, that is as similar. So thread picks column J and loops through the row I. So it performs the addition column wise. Okay. Then coming to the main function. So let's analyze how actually this workflow works on. So we define, so n, we define n equals to 10. So that means actually matrix are 10 into 10. Okay. So then we allocate the memory of the matrices A, B, and C. So using malloc function, so that is fine. Then we initialize A with all ones. And then we initialize B with all twos. And C with all zeros. Okay. Then we allocate the memory of the GPU for three matrices. And that's done enough. So then we copy the matrices. So CUDA malloc void size of the float. So we copy the matrices A and B from the host memory to device memory. Okay. Then we launch the CUDA kernels. Okay. Then is the set of 32 and 16. So 32 in x direction, 16 in y direction. So DIM grid actually calculates how many blocks we need to cover the all elements, the whole elements pattern wise. So matrix add B on the GPU actually adds the elements A and B element wise there is an adding of matrices. So after the kernel finishes, that copies the result matrix C. Okay. After the kernel finishes, copy the result matrix C and then back from the device to the host. Finally, it prints matrices C, A, B, A, B, C and verifies additionally work they are correct or not, and additionally it verifies. So then you will be getting a complete set of threes. Logically, if A is 1 and 2 is A is 1.0, B is 2.0 and 3 is C will be 3.0. So let me summarize this whole. Before that, CUDA free DA, this will be like, this is actually you will be freeing up. So there's no further leakage. That will be the version of this part. So this is a CUDA program actually, um, which runs with the GPU, where the matrix addition of A, B, C is done, and this actually uh, preserves and this gives an exact clarification where with thousands of GPU matrices, threads add matrices efficiently, but assigning one thread per element and doing it sufficiently on the CPU is difficult. So, so if in that the last, if it prints the elements with the two decimal precision, and that will be the matrix addition. Yeah, thank you.